Okay, the next one we're going to cover is going to be our inverse cosine function. By definition, it's going to be defined here. Our solution is going to be restricted to the region from 0 to pi. So our visual in our mindset is going to be the highlighted region of the unit circle. Just as a quick example, y equals the cosine of x. If I chose an ordered pair for this equation would be 0, 1. So y equals cosine inverse of x would be an ordered pair 1, 0. That's just an example similar to the one we did with the sine. So let's take this to the next page and work some examples. Okay, our first example is the cosine inverse of -1. I highlighted our region to which our answer is restricted to, from 0 to pi. And now we say, what angle would you have to take the cosine of to get 1? -1. Oh, this should be +1. Sorry, I wrote it down wrong. What angle would you have to take the cosine of to get +1? What is it? 0. Good. What angle would you have to take the cosine of to get +1? That's here. Okay, let's do another one. Let's just go ahead and do this one since I wrote it down wrong the first time. What angle would I have to take the cosine of to get -1 in our highlighted region? The cosine's the x value, remember? So what would that be? Pi. Good. Okay. What angle do you take the cosine of to get square root of 2 over 2? The x value of square root of 2 over 2. What do you get? Right here, which would be pi over 4. Okay, and one more on this. A cosine inverse, what angle do you take the cosine of to get -1/2? X value of a -1/2, that's right here, so the angle is 2 pi over 3. Let me put that in blue. 2 pi over 3. Okay. Okay, next we're going to do inverse tangent, our definition. And we can see that it's defined from -pi/2 to pi/2. So sine and tangent have this inverse, sine and inverse tangent have the same regions. Cosine's the only one that's the top portion of the unit circle. So that should make it a little easier for us to remember. All right. Now, there's also a table I want to plug in for you. We'll do that on the next page. Okay, before we set up the table, we're going to recall tangent of theta is defined by, it's the same thing as the sine of theta over the cosine of theta, or the y value divided by the x value. So the first one I want you to try is the tangent inverse of 0. So what angle do you have to take the tangent of to get 0? Now that's going to take a calculation, but this one's not too hard, so you can probably do this one on your own. And what's that going to be? 0, because the y value over the x value would be 0 divided by 1, which is just 0. So the answer to this one is just 0. Okay, your next one's going to be the tangent inverse of -√3. So the hard part is finding the y value divided by the x value that's going to simplify to this. So we got to find out which one of those has a y value divided by an x value that simplifies to this. Let's do some work with that. Okay, the first thing I'm going to do, this y value divided by this is just 1. So I know I'm either working with this one or this one. So I'm just going to start with the top one and I do the y value divided by the x value. Well, that's the calculation I have over here. And so when I multiply by the reciprocal, 2 over 1, and I multiply the top by the reciprocal, I just get the square root of 3 over 1, which is square root of 3. Well, I'm liking that I get square root of 3, but mine is negative. So basically, I need one of the values to be positive and one's negative, but the same 1/2 comma square root of 3 over 2. Well, that's down here. Now one's positive and one's negative, so I can say 5 pi over 3 is the answer. Or, since this was given to me in a negative function, what would I say is the negative angle of this one? Okay, well, follow your way back up to the one that's on the other side, so it would be pi over 3. So this is to go in the direction negative pi over 3. So you can see that the tangent is a little bit more work because we actually have to do some calculations. I'm going to go ahead and give you the tangent table in a simplified format so that you can look at it, and it'll make these solutions a little bit quicker for you. But this is how you'll actually calculate them if you didn't have this table. Okay, on this page, if we calculated the y values over the x values for all of these thetas, then this will be our simplified form. So this is just the simplified version of all of the calculations. Also, this is given in the negative angles and the positive angles. So that's just a reference chart for you. Okay, these next set of examples we're going to be working with the calculator to find inverse functions. Make sure your calculator is in radian mode. On my TI-83, I have to just hit mode and change it to radian. Okay, the next thing is I'm going to do sine inverse. On my calculator, I have to do second calculator. I'll just do a calculator button. I have to do second, and it looks like the sine button. Second sine, because underneath it on the bottom side is sine inverse. That looks like that. So you want to plug that in, and then you'll put in 0.5. And in the calculator, what does that give us? 0.52. Okay, now 0.52, we want to make sure that this answer is in our value. Now, we said for the sine inverse, it's from negative pi over 2 to pi over 2. What's the decimal value of pi over 2? So pi over 2 is approximately, what, 1.57 as a decimal. So we're between negative 1.57 and positive 1.57, right? So is that in our value? Is that in our range? Yes. So our answer is negative 0.52. Okay, let's do another one. Let's do cosine inverse of 0.6. So go ahead and be doing that. Cosine inverse of 0.6. Put that in your calculator. You would do second cosine, because underneath it would be cosine inverse. I get decimal 927295218. Just around the two decimal places, I got approximately 0.93. Now the cosine is between 0 and pi, and so is this in our range? Yes, so our answer is just 0.93. And our last one we're going to do is tangent inverse of 5. Okay, so you'll hit the second tan button and then put 5 in, and I got approximately, rounded to two decimal places, 1.37, which tangent is from negative pi halves to pi halves, and pi halves is about, so that's negative 1.57 to approximately positive 1.57, and this answer is in that value as well, in that range.